All right. Hello, everybody who's watching at home. Yeah, we're on red now. Red. So yeah, red. Yeah, I just switched to red. I just switched to red. Okay, we're gonna solve absolute value equations. We learned about absolute values. They're on red. Yeah, yeah. Put that on. Yeah. Oh, you're getting your song ready. Okay, and now keep it away. Like, okay. You got a playlist queued up or just one song? Okay, so you don't have to go back to it. Okay, good, good, good. I got lots of playlists. I have about like 85 playlists. Yeah, 85, and they all start with Corpi, Korpi. So if you type in Corpi and put a space, you'll get. Yeah. Oh, I don't know. I don't know. Just every time I get in a new mood, I just make a new playlist. Yeah, Spotify. Yeah. Um, so absolute values are going to create a disjunction. What's a disjunction? I know y'all been reading while I've been doing all that stuff, right? Just don't read now. Don't read now. Don't read now. Don't read now, Grayson. We've talked about disjoint, haven't we? Disjoint, where it's two separate things. Disjoint, yeah. Disjunction is kind of the same thing. Disjunction just means two separate equations. So the reason we have to have two separate equations when we're solving absolute value equations is because the thing inside of it could be positive or negative, right? Because once you take the absolute value, of course, it's positive, but if it's inside there, it could be positive or negative. The absolute value of -5 is the same as the absolute value of 5. There's two values. So uh, this one let's do this graphically. Okay, so the parent function is our V for victory graph, right? Remember, it bounces at the origin and it has a slope of 1, -1. This is the absolute value of x. What does this transformation do to it? The 2 is a vertical stretch by a factor of 2. Let's do that first. Let's do that first. That means the slope. When you have a number outside here, plus or minus this number equals your slope. Okay? Plus or minus that number equals your slope. So I'm going to go to the origin right here, and I'm going to go up 2, right 1, up 2, right 1, and that'll create the right side of it. And then I'm going to go up 2, left 1, up 2, left 1. There's two different branches. The slope could be positive or negative. So now I'm going to draw this in here like this and like this. So there's what I'm dealing with. That basically took my parent function. If you want to draw your parent function in here, remember your parent function just passes through all of these little diagonals because that's the slope of 1. This would be your parent function. I'll draw it in there as a dotted line. So now you can physically see that it's twice as tall. And since I have it in there, let's go ahead and show. I'll erase this, but I want to show you when we vertically stretch by a factor of 2. It's like taking this value here and pulling it up to there. Taking this value here and pulling it up to there. Taking this value here and pulling it up to there. Notice the lines are different lengths, aren't they? When you dilate something, it's not the same amount every time. The bigger the number, the more it moves, okay? So we're stretching it. Okay, I'm going to get rid of those. They get in the way. All right, now I drew my absolute value V with one stroke because I wanted to pick it up and move it. What are we going to do here? We're going to pick it up and move it what? What does the -5 do? Right 5. And the -4? Down 4. Down 4. Right? My dog's name is 5, so I always say down 5. But my neighbor's dog is 4, right? And the neighbor on the other side of his name is 6. All right? That's like 666. They say that's the number of the beast, but 667 is the neighbor of the beast. Anyway, I thought that was funny. We're going to pick it up and move it right 5 and down 4. So let's do that. I'm going to do it with one stroke here. So right 5, a 1, a 2, a 3, a 4, a 5. And then down 4, a 1, a 2, a 3, a 4. There it is. Don't that pretty? Yeah. Very pretty. It's pretty. Don't that pretty? That's how they say it in Cajun land. Don't that pretty? Now notice, where's the vertex? The vertex is right here. 5, -4. Is there a way we could have told that, determined that from the original equation? Yes, it's right here. There's your H and K or whatever, your C and your D, right? Oh, it'd be -4. Yeah. Okay, now it says to solve it graphically. I want to know where that graph is equal to 2. So I'm going to come up here on my graph, and I'm going to draw myself a line at 2. And I'm going to make it large and in charge, right? So I'm going to come up to 2, and now I'm going to draw a horizontal line. The solution to the equation is going to manifest itself how on the graph of these two functions? It's going to be the what?
The zeros?
Is it the zeros of this function? Are those the solutions?
Oh, no. It's
No.
at the intersection.
It's where they intersect. Yes. The points of intersection. The points of intersection. Yeah, mine is not quite. It looks like it's. Does it cross? 1, 2, 3, 4, 5, 6, 7, 8. So it looks like 2 and 8.
Yeah.
Yeah, yeah. If 2, 8. This is not the best way to solve, is it? You can already tell that this is not the best way to solve an equation because
It's not perfect.
it's not perfect, right? When we draw it, there's some variation there, and we don't really draw it to scale or exact like a calculator or a computer would. So this is a good idea if you want to get an idea of how many solutions there are. I can tell it intersects twice. I know there's 2 solutions. I know that the solutions are roughly 2 and 8, but it could be 2.1 and 8.3. I don't know. I don't know. So that's why we're going to solve them algebraically, because when you do it algebraically, the numbers don't lie. Are y'all okay with me sitting up here with my feet up like this? It makes a table so I can write. It's kind of nice. Yeah.
Does it stretch? Like, are you getting a stretching?
No.
That would hurt me.
Oh, this one?
That would hurt. Yeah.
Oh, no. I'm not really even that flexible, but I guess this way I am. I guess I have teacher flexibility. That's what this is.
Yeah.
That's right. Years and years of practicing. Okay. All right. Are the glasses getting in the way too? Are they obscuring the message I'm trying to send out? Okay. All right. So we'll say x equals 2 or x equals 8. And in roster notation, some of the people missed this on the test. Remember, a roster is just a list. And we use the set notation like that. So roster is a type of set notation. We have set builder and roster. Set notation has set builder and roster. Okay. That was fun. Fun easy. But as we said, solving algebraically is going to be a little bit better, okay? Because it's going to be more exact. Is that what you said, Sloan? It's not exact? It's not perfect. It's going to be more perfect, all right? So here's how we're going to solve these things algebraically. I'll run through the steps before we start. Number 1, isolate the absolute value on one side of the equation. So just like if we had a radical, we would always isolate the radical. We need to isolate now. Or did we isolate the radical? Maybe that was in my dreams. I don't know. Isolate the absolute value. Okay, once we do that, we're going to rewrite it as a disjunction. We're going to drop the absolute values, and we're going to set the contents of the absolute values equal to the right side, and then we're going to set it equal to the opposite of the right side. Okay, and the reason we could do that is because the absolute value of A is A, and the absolute value of negative A is also A. So we don't know what was in there originally if it were positive or negative. So that's why we have to create that disjunction. All right, disjunction, junction, what's your function? Solve each absolute value across an algebraically. Graph the solutions on a number line. All right, the number lines are provided for us down below. All right, here we go. Fun, 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 fun. When it says to isolate the absolute value, it means this right here. This part right there. We need to isolate it. Isolate it. All right, so pretend that that's just a big variable x. I need to add 2 to both sides and then divide by 3. So I'll do that in 2 steps. We got 3 times the absolute value of 4x minus 5. Red Rover, let negative 2 come over, and now it's positive. So 19 plus 2? 21. Cool. Now I need to divide by 3. I don't show it, I just do it. It divides out on the left, and I'm left with the absolute value of 4x minus 5 equaling 7. Oh boy. Did I isolate the absolute value?
Yes.
I did. This is where we stop for a quick break where we pat ourselves on the back. Pat yourself on the back. Now the break's over right after that. There you go. Just remember that man cannot propel himself forward by patting himself on the back.
Just like.
I mean, how hard are you hitting yourself? All right.
How flexible are your shoulders?
Yeah. Okay. Yeah. I was trying to be profound, but yeah. Okay. You ready? Let's create our disjunction. We're going to do 4x minus 5 equals 7, and 4x minus 5 equals what? Negative 7, the opposite of 7. There you go. I'll put an or in here. We only use like the union symbol when it's an interval notation. Hey, this is the gift that keeps on giving. It's one math equation and it turns into 2. Oh man, we get twice as much math to do. That's fantastic. All right, now we'll add 5, so we get 7 plus 5, which is 12. And we divide through by 4, and we get x equals 12 fourths, which is 3. Over here, we get 4x equals, we add 5, and we get negative 2. And we divide through by 4, we get negative 2 fourths, which is negative 1/2. Okay? All right. Now, do they work? Let's try them out. Let's try them out. Let's try out the 3. We're going to plug it way back into the very top. Plug in the 3. 4 times 3 is 12. 12 minus 5 is 7. The absolute value of 7 is 7, right? And then 7 times 3 is 21. 21, take away 2, 19. Man, I'm good. I should go on America's Got Talent and just put this up here and be like, x equals negative 1/2. Let's do the negative 1/2. 4 times negative 1/2. What's half of 4? 2. But now it's negative, right? So I get negative 2 minus 5. What's negative 2 minus 5? Negative 7. Oh, man, it's negative. Bummer. But it's the absolute value of negative 7. So now it's positive 7 times 3 is 21 minus 2 is 19. It works. It works. It works. Lo hicimos. We did it. We did it. Yeah. We went through the absolute value forest. We did it. We did it. We did it. Did y'all watch Dora? Or y'all? Okay, y'all are acting like you don't know what I'm doing. Yeah. Lo hicimos. Yes, ma'am. Question? Did you have a question? Oh, you watched Dora? Yeah. I watched it with my kids, like even after they quit watching it. I like that's a good show. It's a good show. Yeah. Yeah. I do like yelling at the TV. 1, 2, 3. Y'all do this one on your own. Go. No, it's not a race. I don't have any prizes to give. These were just given to me in the hallway, and I adore them.
Wow. You're so blessed.
I am really. I said, "Hey, I like your glasses," and she goes, "Do you want them?" And I'm like,
Heck yes.
"Well," I said, "I don't want to take your glasses." She goes, "No, they're yours." And I'm like, "Okay." And then I said, "What's your name?" And she goes, "Anonymous." And she walked away. No, it was Sophia Bendeley. Sophie or Sophia? Sophia. Yeah. She plays, right? So she can't wear them during the game. I guess that's why she gave them to me. Yeah. Yeah, so I can represent.
So there's like 2 solutions.
There will be 2 solutions. Yes, yes, indeed. Indeed, there will be 2 solutions. Fun, 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 fun. Wait, I missed fun. There's another fun in there. I missed it. Yeah. You know, getting it? Yeah.
This, I don't feel like that's.
Oh, I mean, that's a decent number, right? 14 thirds. I would get 14 thirds. Yeah. 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 If you get funky numbers in here, that's okay. This is honors, man. We deal with funky numbers all the time. Yeah. Oh, 4 thirds? Well, how'd you get that?
That's supposed to. You're supposed to.
Oh, did you bring? Okay, -5, -4. Oh, yeah. How'd you get 8? You multiplied both sides
Yeah.
by -2. You got to divide because you're currently multiplying. You got to undo multiplying. You got to divide both sides.
So it'd be two.
2. Yeah, 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 yeah. Yeah, there you go. But 14 thirds is a great number. All right. Remember when you solve an equation algebraically. I don't know if your teacher told this in Algebra 1, but you're peeling back the layers. You're doing the inverse operation in the reverse order, just like we do when we find inverses. All right, I'm gonna catch up with y'all. -2, 3x minus 6. This equals -4. And we got to divide both sides by -2, so we get 3x minus 6 equals +2. And now it's time for our disjunction junction. What's your function? Or 3x minus 6. Did y'all do harmony over there? Oh, oh wow. Oh. Okay, now, once we split it into 2, now we're back like in Algebra 1 again. It's just easy. It's kind of fun because you know how to do it, right? Bring the 6 across, you get 8, and you get 8 thirds. Did y'all get 8 thirds?
Yes. Yep.
Did y'all get 8 thirds over here? 3, oh, because you did in your head. Hey, if you do it in your head and you get it wrong, then just go back to doing it not in your head. Yeah, I'd rather you get it right than get it wrong. Okay? And this one is 3x equals 6 minus 2.
What?
I'm adding 6 to both sides, so 6 minus 2 is 4. And I divide through and I get 4 thirds. Thirds. Oops. 4 turds. Ooh. Clean up on aisle 3. Aisle 1 has barf on it from Grayson, and aisle 3 has 4 turds in it. We need to. Yeah, yeah. No, I was walking over to the library to take my yearbook photo during a lunch, and I cut through the grass, and I almost stepped on 4 turds. There was like some deer poop. It was deer poop. The 4 little balls. Yeah. And I went, look, there's 4 turds. And look, now we're in here, and what do we get 4 turds, right? Yeah, yeah, yeah. Do you know that the repeating decimal, this is just off to the side, the repeating decimal 0.3333333 is the same as point forest.
What?
Well, if you say 3 differently, tree, right? Tree. Oh, you mean a forest. Yeah, it's just a good old math joke. These are the things we talk about at the math party, like Mrs. Lincoln and I like ha 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 ha.
All the time.
Yeah. All right, let's plot our solutions, right? Why do we have to plot our solutions? Because it says so. Here's 3, and here's -1. There's -1/2 right here. Yeah, and over here, oh yeah, 4 thirds. So that's 2 thirds, 2 thirds, 4 thirds would be here, right? And then 8 thirds. There's 4 thirds, 6 thirds, 8 thirds would be here. I'm glad the x-axis was marked off in 2 thirds. It told me what 2 thirds was. Okay. That's not too bad, right?
No.
Okay, now, there are some special situations. Right? Everything that we've done so far, or the 2 that we've done so far, when we've isolated the radical, are y'all listening? When we isolate the radical, thank you, it's equal to a positive number. See how the 7 is a positive number? And over here on the next example, it was equal to 2, a positive number. When you have the absolute value equal to a positive number like we had, there's always 2 solutions. 2 solutions. 2 solutions. Yeah, I can do this trick too. Watch, watch. See this? Watch. Yeah. Now watch. Got them apart. Yeah. Thank you. Thank you. All right. Now, what if the absolute value is equal to 0? What if you get the absolute value and it's equal to 0? You could break it down into two numbers, right? It equals positive 0 or negative 0. But wait, positive and negative 0 are the same, right? So guess what? There's only one. This is good theory. I might ask this on a quiz, right? When will there be 2 solutions, 1 solution? When it's equal to 0. When there's positive, there's 2. Right, yeah, yeah. So positive, you get 2. 0, you get 1. What about if you have a negative number?
There is no solution.
No solution. There you go. There's no solution. Because when you take the absolute value of a number, it has to be positive. So there you go. All right. Let's try these real quick. Let's isolate the radical. I got to subtract 1. So I get the absolute value of 2/3 x plus 6 equals 0. Ha ha ha! One solution, right? 2/3 x plus 6 equals 0. Plus or minus 0, you can say, oh, that's the same. So that's how you know. And now we just simplify. 2/3 x equals negative 6. And how do we get rid of the 2/3 on the left-hand side? Well, something to do with flipping it. We multiply both sides by the flip version of it. Yeah, the reciprocal. Thank you. Yeah. So put parentheses around everything and put 3/2. 3/2. That's how we say that number, 3/2. Or 3/2 if you like to. And look at this. This is what I like to do. We're left with x equals, and this is really over 1. So if you multiply straight across, instead of dividing, you get negative 18/2, which shows. No, when you multiply fractions, you multiply straight across. Or you could cross divide. That's what I was going to do. Yeah. If you cross divide, you'll see that 6 divided by 2 is 3. 3 times 3 is 9, so it's negative 9. Either way. I always say go small before you go big. Especially when you don't have a calculator. Because if you go small, you're keeping the numbers manageable. If you go big, they can get out of hand. So instead of multiplying to get 18, which is unfathomably large, and then having divided by 2, we'll go 6/2 is 3. Make it smaller first, and then multiply by 3. So look to subtract before you add. Look to divide before you multiply. And look to take square roots or fourth roots before you raise it to a higher power. Okay? Unless you're stuck, then you just got to give it up to the higher power and hope that he helps. Okay. Yeah, I guess. I don't know. So yeah, it never hurts, right? All right. Let's do this fella by ourselves. No, I'll do it with y'all. Negative 5, absolute value of x plus 1. We subtract 2 and we get 10. Then we divide through by negative 5. What's 10 divided by negative 5? Negative 2. Wah, 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 wah. Thank you. No solution.
Oh, just like that?
Yeah, that's all you got to do. No solution. Or you could put something like this.
Yeah. Right.
Yeah, right.
We did on the test when you count right.
Yeah, if you put no solution or, yeah, right. Yeah, there you go. No, let's not abbreviate too much. You can do this. I know solution's a really long word.
No.
SOLN is the appropriate abbreviation for solution.
So there's 3. Colon.
Yeah, and you could abbreviate no with the letter N, and then you could abbreviate solution with S, but then you can abbreviate NS just with an N. And then both of those you could just abbreviate with a dot. So if you just put a dot, I know what you mean. No, I'm kidding. I'm kidding. This is in jest, tongue in cheek, right?
Well, you said that really seriously.
I know, that's my sense of humor, right? I just try to be the, yeah. Okay, don't do that. Don't abbreviate too much, right?
Oh.
Because remember the goal is to be understood. We want to communicate our results.
We don't want to.
All right, so far so good so far? How we doing on time? Plenty of time?
Yeah.
Okay. 2:09?
Wow. 19.
I don't know, but I'm with you. I'm ready to leave.
Me too.
What time do we get out?
2:18.
2:18.
2:28.
2:28. 2:28? I can't really see well through these glasses. It's 18. We have 18 minutes. No, I have like over the years I've collected lots of. I snorkel the river every summer, so I get lots of glasses.
Oh.
And someone gave me these, but I have a red pair like this. I have like a box under my bed that has all kinds of colorful, interesting glasses. It's my dress-up box. And then my whole attic, you walk down because I have a huge walk-in attic. It's like, okay, this is the aisle for clown costumes, and this is the aisle for Western costume. I have like it's like my costume closet. So anytime there's something going on at school, I go up in the attic and I'm like, where's my hula box, right? And I get my Hawaiian box, yeah. Or but I didn't know it was neon today, or I would have worn neon, right? So yeah, it kind of goes.
I
Yeah,
have a question.
yeah.
So you know how there's like extra small and extra large?
Is there an extra medium?
Yeah.
Yeah.
What would it be like?
Extra medium? Extra medium would just be no, it would just have it would have like blinking lights on it
Oh, it's because it's extra.
because it's extra.
Okay.
Yeah. How's that for an answer?
Sounds good.
Yeah, okay. All right. So, hey, real world problems. Like when you walk out of here today, you might encounter this. A laser. A laser is raised 8 inches up off of a reflective table and pointed so that the beam hits the table 10 inches from the edge. I'm going to stop right there and label something. Okay, so here's this. This is 10 inches from the edge, right there. Okay, what else? The laser beam follows a path defined by this absolute value function. Oh, thank goodness, they're giving me the equation. But notice it's not f of x, it's v of h. Okay, where v is the vertical height and h is the horizontal position. So notice the vertical height is a function of the horizontal position. Use an absolute value model to find the horizontal position or positions where the laser beam is 5 inches above the table. So we want to know where it's 5 inches above the table. It might be here and it might be here. Okay, so this has to be 5. So is 5 inches an h value or a v value? So I should plug it in. I should say v of 5 equals 4/5 times 5 minus 10. Is that what I should do? Ah! Look. It says h is the horizontal position. So if we make this the axis right here, this is the y-axis. This is the horizontal position axis, and this is the vertical position axis. So I want to know where it's 5 inches. Look at this. What does this word say? Yeah, good. It says above the table, not to the right of the table. But I really, really like your ability to just amicably agree with me. Sure, he said. No, it is a V value. It is a vertical value. So I must set it equal to 5. Okay, and that's an important thing. And now we have to solve it. I better, no, I'm sorry. I'm trying to read, this is wrong. Good. I need to set the function 4/5. Thank you. I was going cray. I set it equal to, I wasn't going cray. I was only going single cray. I don't think my wife would let me go cray. I can imagine it. I could talk about it maybe, dream about it. Yeah. I mean, I'm really only allowed to do one. What do we do with the 4/5 to get rid of it? Yes, we put parentheses. Thank you. We put parentheses around this side and this side just to be careful, and then multiply by the flip, right? The reciprocal, 5/4, 5/4. And now look at over here. We're left with the absolute value of h minus 10 equaling, oh, what the heck? What's 5 times 5/4? 25 fourths. We put it over 1 and we multiply straight across. 25 fourths. Okay. Now what? Now, is that a positive number? So it's going to have how many solutions? 2. That's 4. Sorry. 2. 2. So we go and we create our disjunction. Disjunction, junction, what's your function? I give 2 solutions. I don't know. I'm just thinking out loud of a song. Yeah. And then there would be a bridge.
Wouldn't one be negative?
Yes, one would be negative. It doesn't make any sense to set them both equal to positive. So there you go. One's positive, one's negative. H minus 10, we drop the absolute values. Now, all we got to do is solve. So we add 10 to both sides. So 25 fourths plus 10, or 10 minus 25 fourths. I'm going to put it in front. I don't like to lead with negatives. I don't know. Let's see. 25 fourths. Yeah, I do. That's 10 over 1. So I got to multiply by 4 over 4. So that's, oh yeah, very good. Someone already said it. 65 fourths. I think that was Sloan. Yeah, that's right. And over here, we get a common denominator. Again, we multiply by 4 over 4, right? Multiply by 4 over 4, and we get 40 fourths minus 25 fourths. And this becomes 15 fourths.
Nice.
Now, are both of them legit? Well, let's see. Yeah, I think they're both legit. They're both positive, right?
Yeah.
Yeah, so that looks good to me. Um, do we know what these are horizontal values? Yeah, that's reasonable, right? We would have one here, and we'd have one here. So we got 2 solutions. All right, now, because this is an application, once you get your numbers, you should come back and always consider units. What are the units of the horizontal movement? We're talking inches. So the last thing we do is put inches, IN, inches, IN, which is a customary abbreviation. Okay? Don't just put I, because that's the square root of negative 1. Right? Pulgadas. Pulgadas. No habla español? Ganz nicht? Sprechen Sie ganz nicht? Okay. Ich spreche nein Alemán. Yeah, okay. I don't speak any German. Yeah. Spanish either. Yeah, okay. Anyway, there you go. I think that's the end of the notes. How'd it go? That's pretty easy, right? Rest of the period. Yeah, we did it one day. We're getting good. And we didn't compromise anything, did we? I got to tell you a little bit more than what the notes are. We got to yeah, it was good. Well, always a little bit. Okay. You have the rest of the period to work on your. Oh, let me do this real quick. In 2 days, Friday, Monday, Tuesday. Yeah, Tuesday. Let me let me go to Canvas. If you go to Canvas, oh, I do. I know. Okay. If you click to the top on your 853 things, I wonder if 19 of those are to check the inbox. If you click on video lessons at the top there, video lessons, everybody, video lessons. Here, yes, I'm recording this right now, and this will go in this link. You click on it, and it takes you to, we're in, I think this is y'all's. Yeah. Yeah.
Do you record every period?
I did start. I started recording. No, just one period, just y'all's. So look at this. Look at this.
We're so blessed.
If you were not here yesterday, hey, we're still on red.
I was not here. Someone wait. That playlist was so good.
Yeah. No, we're still on red. I know we're all getting used to the nonverbal cue here, the light, but I spent too much money on this light for it not to freaking work. Okay? So when it's red, keep your phones off the desk. Right. I don't want your phone. I already got a phone and a bunch at home that I don't use anymore. Okay? Algebra, Chapter 2, test discussion. That's what we did yesterday in class. So if you were not here, you need to go over that and then fill in your corrections. And then this one is going to go in here as well. I'll make a folder for, I'll just change the name of the folder and I'll just call it math. And then I'll put all the videos in here. And you'll be like, oh, math. Now, when you're searching, like if you're ever searching, just click last modified and it'll throw the most recent video to the top. And you're like, that's the one that I missed when I was absent. Now I'm going to watch it at home 5 times. I'm going to get mom and dad to sit on the couch with me, and we're going to watch it together, and I'm not going to miss a thing. And we're bonding, and now we love each other even more. And I'm caught up when I get back to school. Okay. Sound good? So it's in there. All right. Y'all have the rest of the period to work on y'all's worksheet or your homework. And now watch. And now the light goes to green. Yeah. Okay. Yeah. Green. Full throttle. Okay.